Okay guys, welcome to Worm's Maths Academy. This is Worm Part 2 for the 2018 Northern Hemisphere exam. I'm going to try and run through it with a CAS to make sure that we do it as quick as possible. So, first one, x to the 4 minus 4x minus 8. Oops, I don't want that. I want to open up this, clear off everything we were doing before. Okay, x to the 4 minus 4x minus 8. I'm going to define that. Okay, what does it ask us to do? Given fx equals x minus 2. Okay, so we want to factorize that. F of x. Okay, back one. Okay, so we've got 2 and 4. So A equals 2, B equals 4, C, nearly missed C, C is 4. Okay, find two consecutive integers m and n such that the solution of fx equals 0 is on the interval m to n, where m is less than n, which is less than 0. Okay, so both my answers have got to be less than 0. Let's graph that graph. F of x. Okay, so it's not going to be the solution at 2, it's going to be the other solution, which is that one there. G solve root. Okay, so x is negative 1.29, so it's going to be negative 2 and negative 1. So the lower one, m is negative 2, n is negative 1. Shows part of the graph of f in a straight line through the point 0, negative 8, 2, 0, part of the graph of f. A second straight line is drawn parallel to the horizontal axis and touches the graph f at the point Q. Okay, so that's the axis and that's the point Q. Find the equation of a line through 0, negative 8, and 2, 0. 0, negative 8, and 2, 0. Okay, so our rise is 8, and our run is 2, and we've got a y-intercept of negative 8. So y equals 4x minus 8. Set the equation of the line passing through the points P and Q. Okay, so what's the turning point of that? Is that graph? Zoom out. And also G solve. Oops. Negative 11. So it's a turning point there. So y equals negative 11. State an coordinate to the point P and Q. Okay, so x equals 1. So Q is 1, 11. P, negative 11, is something negative 11. If we let 4x minus 8 equal negative 11, I get x equals negative 3 on 4. Negative 3 on 4. Okay, a transformation is applied to graph of f. So D is moves it left or right. Find the value of D for which P is the image of Q. P is the image of Q. P, so Q, it's got to be moved left, negative 7 on 4. because we want to move it 7 on 4 to the left. Let M' and N' be the images of M and O, N respectively under the transformation T, where M and N are defined in part B. Find the values of M' and N'. So M' is -2 minus 7 on 4. N' is -1 minus 7 on 4. So M' is equal to -15 on 4, and N' is equal to -11 on 4. That was quick, one question down. Okay, robots manufactures 3 types of components: sensors, motors, and controllers. Independence. Know that 8% of all sensors manufactured are defective. Random sample of 5 sensors. Okay. So in this case here, we've got 5 sensors. So N equals 5. The chance of them being defective is 0.8. Okay, so we'll say X is binomially distributed. 5, 0.08, and the probability that X equals 2. Okay, clear everything. Discrete binom PDF 2, 5, 0.08, 0.0498. Don't forget to write this in because that's your 1 marker. Given that, okay, exactly 2 of these, given that at most 2 in the sample are defective. So the probability that X equals 2, given that X is less than or equal to 2, is 0.0498 on X is less than or equal to 2, distribution discrete CDF, 0 to 2, 2, 5, 0.08, 0.08, 0.9955. Okay, so we want it to 4 decimal places, so we're going to go that on that. 0.0501. Okay, random sample of 50 sensors selected, and it's found that the proportion of defective sensors is 0.08. Determine the 90% confidence interval for the proportion of defective sensors. Okay, so 0.08 of that would be 4 out of the 50, and we want a 90% confidence interval. So we'll clear this. I don't know if I can do it through here. I can, but let's go back to graph and no. Statistics, calc, interval, 1 prop Z interval, confidence levels 0.9, X is 4 out of 50. Okay, 0.0169, 0.0169, 2, it must be 0.1431. Okay, a hole is drilled into each motor. The depth of the hole is normally distributed with a mean of 20 and a standard deviation of 0.3. Actually, we should state, we'll say M is approximately normal 20. Remember, it's your variance here, so it's going to be 0.09. Find the probability that the random selected motor, the depth of the hole is greater than. So the probability that M is greater than 20.6 is distribution continuous norm CDF 20.6 infinity. Remember, normal always goes to infinity. That's 0.3. That is 20.0228. Ah, come on. 0.022. Oops, forgot my 0.0228. The depth of the hole during the motor must be within 0.5 millimeters of the mean, otherwise the motor is... What's the problem? The motor is defective. Okay, so it's got to be within 0.5 of the mean, otherwise it's defective. So it's got to be up or... So we want 1 minus the probability that 0.5, so 19.5 is less than M, which is less than 20.5. Okay, 19.5 to 20.5. So continuous norm CDF. That's 0.3. That's 20. So that's 1 minus that. 1 minus 0.9044. Which equals 0.0955. Is that right? 956. What was I thinking? Okay. Rebecca delivers an order for 5 sensors and 5 motors. What's the probability the order contains exactly 2 defective components? So I can have sensor, two sensors, 0 motors. I can have, that's one way. I can have 2 motors, 0 sensors, or I can have 1 motor, 1 sensor. Okay, so from here, what have we got? Our motors are normally distributed, and our sensors are binomially distributed. So I have 5 sensors and 5 motors. What have we just worked out? 5 sensors, and we want 2 being defective. I should call that S just so it makes a bit more sense. So S is binomially distributed, probably S equals 2, S equals 2, S is less than or equal to 2. Okay, so if I want the probability that S equals 2, that's okay, so the probability a motor is defective is 0.0956. So the probability it's not defective is 0.9044. Okay, so we can say M is binomially distributed now with 5 and 0.0944. Okay, so I want 2 sensors defective out of 5, and I want no motors defective. So let's go discrete binomial PDF. Okay, so I want 2 defectives, 5, and what's the chance of one of them being defective? 0.08. Okay, so 0.049, so that's 2 defective, and then we want 5, and we want 3 non-defective, so 5, and then the chance is 0.9044. So we multiply those together. 0.033. Okay, so then wow, this seems like a really long question. So multiply those together, 0.0034 plus 2 defective and 3 not. So that's 3.92, and then that's going to be 2, and then what was it? 0.9044. Okay, so then that, is that right? Times that. So it's the same for 3 as for 2. 2, 3, what was that one? So they probably haven't been defective, so not defective, 9044. It's 0.033. Okay, so 0.0034, and then so I've got that. What is the probability that the order contains 2 defective components? So do we have to have 2 S's defective times 3 S's not defective times hang on. If we had 5, we've already worked that out. So we've got 2 S's defective, and then if we had none defective for the other ones, okay, so let's try that. So none defective out of 5. What do we find out the chance of one of them being defective was? Probability that's defective is 0.0956. Okay. 0.0956. 6051. Okay. So I've got 2 of those defective. 2 of these defective. So if I do that, times that. It's going to give me the answer. Okay, 0.030. So that's our first one. Sorry about the stuff up here. So 2s is defective. Then I want 2 motors defective. So none of these are defective. And then here, 2 of these are defective. So go back and hit enter on them. So it's that times that, 0.0446. And then plus 1m and 1s. So 1, 1. So that times that, 0.9196. So we want that plus that plus that, 0.1664. Now how many decimal places? 3 decimal places, 166. Okay, what did we get that last one was? 0.0916. Okay, that was a pain in the ass. 3 marks, it took me way longer than that. Okay, the numbers attached to each controller. The height of the number is normally distributed to the mean of 30. If the number of the controller has a graph of less than 29.6, then show that 2% of the controllers are defective. What's the maximum standard deviation of the knob that can be attached? So less than 2% of controllers are defective. Okay, so we know that, let's say N for knob, even though knob starts with a K. Knob is normally distributed. Actually, maybe we should use K because K is normally distributed with a mean of 30 and a standard deviation of sigma. She wants to ensure that 2% of controllers are defective. So we'll draw our curve, 1, 1 by symmetry, and it's got to be between, so the probability that 30.4 is less than K, which is less than, 29.6 is here. 30.4, that's equal to 0.98. 2% of controllers can be defective. So let's get we can get a Z value for this because we know if that's 1%, then the probability that K is less than 30.4 is equal to 99%, and the probability that Z is less than A is 99%. So let's get our Z value. Nice, stupid thing. Interactive distribution, inverse. Let's go left and 0.99. So 2.326. Okay, so therefore Z 2.326 is X 30.4 minus mu 30 on sigma. So therefore, to 2 decimal places, sigma equals 0.4 on divided by my last answer, 0.17. So that's our standard deviation if you want to ensure that 2% are defective. Bloody hell, that question seems long. Okay, the weight in grams of controllers is modeled by that. Determine the mean weight of the controllers. Okay, so the mean weight, so E of W is 3W on 64,000, 330 minus W squared this is weird because it doesn't say how many decimal places. Between 290 and 300 dw. Now I put that extra w in there because you know E of x is the sum of all w times the probability of w. So when it's continuous, we have to put a w in there. Okay, so let's check this in our CAS. So, integral, what was it, 290 to 330, bloody hell, I can't remember this, 3x on 64, I think that was 4 zeros, 330 minus x was it squared, and then 290 minus x, there's a bracket, w minus x minus 290, and then dx 306, and that's why they didn't say to any decimal places. Determine the probability that a random controller weighs less than the mean weight of the controllers. Okay, so the mean weight's 306, so we've got to do the same thing, but now we get rid of that, and then we change this to 306. 0.5248. Okay, so we've got to show working. So 290 to 306. What was it? 3 on 64000. 330 minus w squared. W minus 290 dw, which is what was it? 0.5248. 0.5248. Thank God the probability questions are all sick of that. Okay, the front of a building has a length 80 meters and a height of 20 meters. On the front of the building is a glass panel which lies directly on two curves. Got a sine curve and another sine curve. Okay, so what I'm going to do is I'm going to call this f of x and I'm going to call this g of x, and 5 on 2 sine x on 10 plus 15. 5 on 2 sine x on 10 plus 15. Make sure my calculator's in radians. Interactive define as f of x. And then the other one is 25 on 4. And then, so it's very similar. We're going to call it g. Was it 15 on 4? 25 on 4. Plus 10. Now, whoops, not 110, just 10. So, let's go into our graph and table. And I remember it said between 0 and 80. So, I'm going to put f of x here. F of x. G of x. And then we want it between 0 and 80. Zoom auto. Okay, so that looks like our two graphs. Pretty close. Oops, wrong one. Okay, so go back to here. The boundary of curves 0 to 80 with rule Z, where x is the horizontal distance in meters and y is the vertical distance. Find the total area of the glass panel in square meters, correct to 2 decimal places. Okay, so that's the integral. Which one's the higher one? F of x is the blue one. So from 0 to 80 of f of x minus g of x dx. Now because we've got it defined, it's nice and easy. So 0, 80 minus g of x dx. What did it say? 357.04. 357.04. Now I think they used Y1 and Y2, so let's use Y1. If you define them and said let, and then let, you could just use them, F and G. Okay, let D be the vertical distance between the upper and the lower boundary curves. Find the minimum value of D in meters, the value where this occurs. Okay, so D of x is y1 of x minus y2 of x. D dash of x equals 0 for max slash min. Okay, so I'm going to define D of x, difference of x, is f, go back that way, f of x minus g of x, g. Okay, and then we want to find, let's go and graph it. Okay, we want to find when it's a minimum from 0 to 80. So 0 to 80. G solve f min. Not that one. Not that one. That one. 1.25, 1.25. That's two values. Okay, so let's go out. So I want to know when d dx, no, we can just find the min. Calculation f min of dx from 0 to 80. Okay, it equals it twice. And the values of x. Okay, it didn't give us the exact, oh, it's because it's in decimal. Let's see if it gives us the exact. Okay, so min is 5 on 4 when x equals 5 pi or 25 pi. When x equals 5 pi, 25 pi, min value equals 5 on 4. So that's the minimum distance. What's the average value of d in meters? Correct to, okay, so the average height. So 0 to 80 d of x dx with 1 on 80 minus 0, so 1 on 80. So 1 divided by 80, 0 to 80 d of x dx, 4.46, 4.46 meters. The boundary of the curves are generalized, so that's that and that's that. The boundary curves do not intersect. Find the maximal value of P. They're generalized, so A is positive. Do not intersect from A to P. Okay, A squared, and so let's just do f of x and g of x Okay, so we want that. F of x. Stuff it, I'll just do the whole thing again. So let's go, I'm going to say z instead of a. Z times sine x on 10 plus 15, and define that. And then do the same thing with z squared. And then that's 10, and then that is g. Okay, I think that was right. Z. The maximum value of p. So from 0 to p. So get rid of that. Okay. I've got to do given, we'll do given z and given z. So zoom order. Okay, so what can we do here? What have they just got us to do? They want us to find the shortest distance. Was it those 2 points? So if we put in, if we let x equal 5 pi, it's going to be sine of pi on 2. What's sine of pi on 2? 1. So if x equals 5 pi, c1 of 5 pi is going to equal, if I put 5 pi into that, what do I say? I get 1. So I get a plus 15. And c2 of 5 pi is a squared plus 10. Okay. So that's when the shortest distance occurs. Let's let them be equal, because I want to find out. So a plus 15 equals a squared plus 10. So a squared minus a. A squared minus a is minus 5 equals 0. So a squared minus a minus 5 equals, come on, you stupid thing. I think my pen's gone flat. Highlight, interactive, advanced, solve. Okay, so root 21 on 2 and root 21 on 2 plus a half. So a equals root 21 on 2 plus 1 half. Oops. So if a equals that, so that will be my value of p when they first intersect. So therefore, p is equal to root 21 plus 1 on 2. Always pays to go back. I'm like, I don't understand. Root 21 plus 1 on 2. Because it's not inclusive. So, if we were to go back to here, and then I was to say, let z, use settings. Okay, so if I said, let's go bracket, root 21 plus 1 on 2. It should just be touching, which it is. So we know we got it right. Find the V of A for which the area of the glass panel is a maximum. Also state the maximum area in square meters. Okay, so we've got 0 to 80. 0 to 80. A sine. Is it still higher? Yep. A sine. So C1 of x minus C2 of x dx. Did I define them? Yep. So if I went so 0 to 80 of f of x minus g of x dx, I get 342.72. Zero to 80 from that. I got a variable defined. Oh, I do, yeah, from in there. Okay, so that's my integral. And then I want to find when the derivative of that equals 0. So I'll say a is equal to that. So a equals call that a of a, and then I'll say a dash of a equals 0, which is so that's the integral in terms of a, which is this. And then we want to know when that is equal to 0. So edit, select all, derive with respect to z, set it equal to 0, select all, solve for, select all interactive advanced, solve for z. That's nice, z equals a half. Okay, so also value of a, so therefore a equals 1/2, and then a of 1/2 is, so we want this formula, move it down to here, and then say given z equals 1/2, 402.86, was it 3 decimal places? 2. 402.86 meters squared. Okay, one more done. Okay, part of this graph, let's get rid of all the graphs. X minus x log ex. I reckon they're going to make us do integration by recognition. X minus x log e x. I should put a times in between there. Define it as f of x. Let's just go in and make sure that our definition looks the same as what they had. Okay, zoom, initialize. They do look the same, I think. Yep, goes through 1 and E. Find the values of x for which the gradient is between -1 and a half. So let's find when it equals -1. So f dash of x equals -1, f dash of x equals -1/2. What am I thinking? So we could graph f dash of x. Does it want them exact? Yeah. Okay, so let's go out of here and then into here, and then say d dx of f of x. Let's say when it equals -1/2. You want exact. And then when it equals -1. So root e must be smaller. So it must be from root e to e. So we'll say -1 is less than 1 minus, what's the derivative? Negative log ax, which is less than -1/2. So therefore root e is less than x, which is less than e. Find when it's 1/2 and 1. Okay, so there's +1/2. There's +1. E to the -1 on root e to 1 on e. One on root e is less than x, which is less than 1 on e. Okay, find the equation of the tangent of f a in the form y equals mx plus c. So, interactive calculation line, tan line, f of x. Is it at the point A? Negative x log a plus a. Y equals, was it negative x log a? So negative log e a of x plus a, I think it was. Yep. Okay. Find the coordinates of the points of intersection of the tangent of the graph at x equals a and the tangent of the graph at x equals 1 on a. So if we do the same thing, 1 divided by okay, negative log e 1 on a plus 1 on a. Negative log e x 1 on a x plus 1 on a equals negative log e a x plus a. Okay, and then from there we've got to let them be equal. So that is equal to that. Interactive advanced solve for, do you want to solve for x or for a? I want to solve for x. grabbed the wrong thing. Stupid. Like, it doesn't seem right. So there's one, and then there's the other. So that equals that. Interactive advanced solve. Simplify. Bloody hell. Okay. We've got log A minus, so 1 on A squared. Sure, it doesn't simplify. Okay, so the top's going to be negative A squared. Okay, negative A squared plus 1 over the bottom. I've got A on log E 1 on A squared. Now, we could make that log E of A and bring the negative 2 down the front. So I'd end up with A squared minus 1 on, that's going to be log E of A. I brought the negative 2 up and down the front as a power, and then I get 2A on the bottom. So 2A log E of A, so that's my x value. Find the coordinates. So A squared minus 1 on 2A log E A. I wonder if this will give us a nicer value. So f of that. Simplify. Bloody hell. Okay, let's try it with our other answer. F of, what was it? A squared minus 1, stupid thing, on 2A times, was it log E? A? Because I made it A, I think. Why is it so nasty? Let's try put it. Oh, we don't want it in F, we want it in the tangent. This is confusing. Okay, so edit, copy, go down, edit, paste, and then we want it, copy. So we say given x equals edit, paste. That looks better. So simplify, A squared plus 1 on 2A. How many more questions is there left? Sick of doing this already. Okay, hence find the coordinates of the point of intersections of the tangent of f at x equals E and 1 on E. Express each of the coordinates in terms of E. So, points of intersection. So it's going to be the same thing, but x equals E. So I'm going to get E squared minus 1 on 2A log E. That's just going to cancel. Log E of A is just 1. And then I'm going to get E squared plus 1 on 2E. So all I did was sub A equals E. For the value B is greater than E, the tangent of F at the point B, the tangent intersect the x-axis at the same point. So B is greater than E, the tangent to the graph at the point B, FB, and the tangent of F2 intersect the x-axis at the same point. So where is the tangent at F? So let's go tan line calculation line, tan line of f of x at the point 2. Okay, where does that intersect the x-axis? We let y equals 0 and solve for x. Interactive advance solve for x. So at 2 on log E2. So there's another tangent at B. So we can say f equation at f of 2 intersects x-axis at x equals 2 on log E2. Oh, you stupid thing. 2 on log E2. Okay, so let's find the equation of the tangent at the point B. So, interactive calculation line, tan line, f of x at the point, what the hell is B? It's in there. B. Okay, so we can say y equals that. I think the pen's broken down again. Okay, so, or maybe the app's died. Okay, so that equals 0 given x equals that. Interactive advance solve for B. So solve for B. Okay, so B equals 2 or 4. So equation of tangent at B, y equals negative x log EB plus B. When x equals 2 on log E2, B equals 2 or 4. However, B is greater than E, so therefore B equals 4, because E is 2.7. Okay, the tangent at F, where 1 is less than P, which is less than E, and the tangent, the point Q, where Q is greater than E, intersect on the x-axis. Show that P to the Q is equal to Q to the P. Let's go back and have a look. If we did that without making that equal that, and we just solve for B, for x, B on log EB. So at the point 2, that intersected at 2 on log E2. At the point B, it intersects at B, log EB, B on log EB. So at the point P, will intersect x-axis intersect on the x-axis. So P on log EP, and at the point Q, we intersect at Q on log EQ. Okay, so P on log EP is equal to Q on log EQ. So that means that P log EQ is equal to Q log EP, which means that log E of Q to the P equals log E of P to the Q. Therefore, Q to the P is equal to P to the Q. Bloody hell, this is hurting my brain. What was it? Q to the P. Okay. Okay. Find the equation of the tangent at the point where x equals root E. We should be able to just do that from these, shouldn't we? So it should be that with e to the half in it. So it's going to be negative a half x plus root E. Negative a half x plus root E. Let's make sure it is. F of x, interactive calculation line, tan line at the point root E to the 1. Okay, so my thinking was right. Okay, part of the graph of f with a tangent at the point P shown below. E is a corresponding point on the x-axis, intercept of this tangent, yep. F is the point where y equals, yep. G is a point corresponding to the local maximum of f, yeah. H is 1, 0. Okay, find the coordinates of the point E and F. So doesn't E, you think that E is root E on log E. E is so y is 0, but it was root E on log E of E to the half. So it's going to be 2 root E, 0. You could just do it on your calcs. I just wanted to make sure that I was doing it right. 2 root E, so this is E, 2 root E, 0. Now the point F is when that line intersects 1. So equals 1. 2 root E minus 2. Okay, find the area of the quadrilateral EFGH. Okay, so I've got to find the length FG, we've got to find the length HE. So let's say HE is F minus 1, so it's 2 root E minus 1. No, minus 3. That minus that. Okay, and then F, oh you idiot, E. So that's 2 root E minus 1. Because that's 2 root E, and then minus 1 is going to give me that length there. That length there is going to be F minus G. So what's F? That. Also minus 1. So F G length is 2 root E minus 3. Then the height is the value of G, which is the maximum, which we can work out here. F of X interactive calculation max, F max between 0 and 2, 1, 1. So that length, okay, so area is 1/2 top plus bottom 2 root E minus 1 plus 2 root E minus 3 times the height, which is 1. Okay, so I get 2 root E, which is 4 root E. When I have it, I get 2 root E minus 2. Find the area of QGH. QGH. So from 1 to E, is it F of X? Feels like this question's gone on forever. 1 to E, F of X dx. Of course, you don't need to do this because it's 1 mark. So one to E F of X dx of the triangle that. I thought it was strange, didn't say bound by that. Okay, so that length is E minus 1, and that length is, that height's 1. Well, that's weird. So, area of the triangle is 1/2 times base times the height, which is E minus 1 on 2. Find an approximation for the area of the shaded region by calculating the average areas found in part E2. Okay, so 2E, 2 root E minus 2 plus E minus 1 on 2, all divided by 2, is equal to so grab that plus, what was the other one? E minus 1 on 2, so it's not E, E minus 1 on 2, simplify. Oops, we want to divide that by 2. Go back, you stupid thing. That divided by 2. E. So 1 on 4 just wants an answer. So let's just give an answer. I've got 1 on 4 E plus 4 root E minus 5 as a percentage of the actual area. Okay, now I worked at the actual area before, didn't I? Did I delete it? I hope not. I did. Oh no, that's it there. Copy. So edit, paste. Okay, so the actual area is E squared minus 3 on full. Actual area is E squared minus 3 on full. Find the approximation. Okay, so if we do the previous area minus that area and then divide it by the actual area. So if we do that, minus bracket, edit, paste. Okay, so that's our error. And then if we did that, let's put a bracket around it, divided by the original, and then times 100. We'll get the percentage error. Change that to a decimal. What have I done wrong? Oh, I forgot to put brackets around it. Mike, that does not sound right. 1.73%. So then, percentage error is E squared minus 3 on 4 minus 1/4 E plus 4E minus 5 on E squared minus 3 on 4 times 100, which is 1.73%, because it said 2 decimal places. Alright, hopefully, is that it? Hopefully I haven't stuffed anything up. I'm sure there's probably some mistake somewhere. Didn't actually require you to do much without a CAS. So hopefully you got most of it right. And hopefully so did I. Thanks. Good luck. Bye.